Hello students, welcome for the next session of the basic electrical system course. In the today's session, we are going to see the working on the wires. If we have to join two different wires, we have to solder it or we have to connect it in which fashions that we are going to see in the today's session. So let's start today's session. First of all, what is meant by a particular, we can say, solder? A solder is a common material that is used for the wire repair, and it is an alloy of tin and lead. This solder makes good electrical connections between two wires. A flux must be used to help to clean up the area and to help the solder to flow. Solder made with the resins contain the, you can say, solders which are made of the resins, which is contained in the center, is called as a resin core solder. And we have to always use a resin core solder for the electrical or the electronic solderings. We have to use a small diameter solder for the small soldering irons and a large diameter solder for a large diameter, we can say, solder guns or the high wattage solder guns. Solder is available in various percentage of tin and lead in alloy. Ratios are usually used to identify these various types of solders, with the first number denoting the percentage of tin in the alloy and the second number giving the percentage of lead. The most commonly used solder is a 50 by 50, which means 50% of the solder is tin and other 50% is lead. The percentage of each alloy primarily determines the melting point of the solder. For example, in case of a 60-40 solder, which consists of 60% tin and 40% lead, which melts at 180 degree centigrade. 50-50 solders, which melts at 216 degrees centigrade, and 40-60 solder melts at around 238 degree centigrades. The melting points as stated above can also vary depending upon the purity of these metals which are used in the solder. Now, in case of the 60-40 type of the solder, the melting point is low, and that is why it is commonly used for the room temperature applications. When soldering wires, be sure that they heat the wires, not the solder. Okay, using a soldering gun or the butane such as shown in the figure. Okay, now soldering a wires involves a particular steps that which we are going to see. While touching the solder gun to the splice, apply a solder to the junction of the gun and the wire. Okay, now next is, due to this arrangement, the solder will start to flow. Do not move the soldering gun in this case. As the solder flows into and around the strands of the wire, keep feeding more solder into the splice. After the solder has flowed through the splice, remove the solder gun from the splice. Allow the solder it to cool slowly. A solder should have a shiny appearance. Okay. A dull looking solder may be caused by not reaching the enough high temperature, which results in a cold solder joint. Reheating the splice and allowing it to cool often restores the shiny appearance. An acid coat solder is also available, but it should not be used for soldering the sheet metals. Now, crimping the terminals. When you solder it, we have to make a seal-proof joint by using a crimping. Okay. Now the terminals can be crimped to create a good electrical connections if the proper type of crimping tool is used. Most manufacturers recommend a W-shaped crimp to be used to force the strands of the wire into a tight space. Okay. Now you can notice here to create a good crimp, open the part of the terminal is placed into the jaw of the crimping tool towards the anvil and the W shaped part is produced. Now, most vehicle manufacturers also specify that all hand crimp terminals or the splices should be soldered. Okay. Now, this next important part is the heat shrink. Okay. Usually, these heat shrinks are made from a polyvinyl chloride PVC or the polyolefin. The heat shrink tubing shrinks to about half of its original diameter when it is heated, and it is called as 2:1 shrink ratio. Heat shrink by itself does not provide protection against corrosion because the ends of the tubings are not sealed against the moisture. Now, certain manufacturers recommend all the wire repairs that may be exposed to the elements be repaired and sealed using the adhesive line heat shrink tubing, which is usually made from the flame retardant flexible or polyolefin with an internal layer of special thermoplastic adhesive. When heated, this tube shrinks to 1/3 of its original diameters, and the adhesive also get melted, sealing the ends of the tubing. Now you can see in this figure, a butane torch is especially designed to heat shrink, which applies the heat and which also do not causes any damage to the other parts of the wire. Now there are these type of seals which are called as a crimp and seal connectors, and these are generally used by the manufacturers such as General Motors or the Ford Motor Company, and these are also used for the wire rebel. These are not simply butt connectors, they contain the sealant and that string tube in one piece. This type of connectors is first lightly crimped to retain the ends of the wires, and then it is heated. The tubing shrinks around the wire splices and the thermostatic glue melts on the inside of to provide an effective weather resistant seal. Now there is a particular procedure that must be followed by using these crimp and seal connectors, and which is as follows. Step number 1 involves to strip the insulation from the ends of the wires. Now step number 2, we have to select the proper size crimp and seal connector for the particular gauge of a wire. Insert the wire into the splice sleeve and crimp. Apply the heat to the connector until the sleeve shrinks down around the wire and a small amount of sealant is observed around the ends of the sleeve. Now next important part is the repairing of an aluminum wire. Many automobile manufacturers use a plastic coated solid aluminum wire for some body wiring. Because aluminum is brittle and can break as a result of vibrations, it is only used where there is no possible movement of wire, such as along the floor or the sill area. This section of the wire is stationary and the wire changes back to the copper at the junction terminal after the truck or the rear section of the vehicle, where the movement of wiring may not be possible. Now, since the aluminum is protected by using a plastic conduct, normally a seal, after which the wire can be easily removed for repair. The following procedure should be used to assure for a proper repair. First step is you have to carefully strip the wire from the insulation. Okay. Next step is use a crimp connector to join the two wires together. Do not solder an aluminum wire repair. Solder will not readily adhere to the aluminum because heat causes an oxide coating on the surface of aluminum. To prevent the corrosion, the spliced crimp connection must be coated with a petroleum jelly. The coated connection should cover with a shrinkable plastic tubing or wrapped with a electrical tape to seal out more moisture. So in this way, we have studied in the today's session how to do the wire repair, how to solder the different types of wires, the types of the crimp seals, the crimping method for the wiring connections we have seen. Okay, so this is a common practice during your practical sessions. You must be doing such type of connections. I hope you have gone through these connections in your practical. So if not, please go through it, and it is a must for any electrical technicians. I hope you have understood the today's session. So we will see in the next session the important concepts regarding the electrical systems. So thank you. See you in the next session.